Welcome back, everybody. Today we're going to be diving into something pretty interesting. Fever. You
Yeah.
know that feeling you get when you get sick and you're all like achy and chilly and just...
Yeah, definitely.
Well, turns out that's not just a sign that you're under the weather.
Right.
It's actually a really old defense
Yeah,
mechanism.
600 million years at least.
Wow, 600 million years.
At least.
That's older than dinosaurs.
Way older.
That is amazing to think about.
It really is.
And it's also way more fascinating than most people probably realize.
Yeah, I think so.
So what is fever really all about?
Well, it's like your body turning up the heat, literally, to fight off anything that's trying to invade.
Okay.
Bacteria, viruses, things like that.
So it's like our body is going to battle mode.
Exactly. And it's not just us humans either.
Oh, really?
Yeah, you see this across a bunch of different species, like, fish.
Yeah.
They'll actually seek out warmer waters if they get infected.
Oh, wow. So they're trying to give themselves a fever almost.
Yeah, kind of.
That's interesting.
And lizards, they like to bask in the sun.
Right.
Well, they do that even more when they're fighting off something.
So they're like soaking up those rays to boost their immune system.
Exactly. It's like a universal language of defense.
I like that. A universal language of defense.
And for us humans, it's a really powerful tool.
Okay, so we know fever is this ancient defense mechanism. But how does it actually work?
Well, it all starts with these things called pyrogens.
Pyrogens.
Yeah.
What are those?
They're basically chemical messengers.
Okay.
Your body releases them when it senses an infection.
It's like our body is sending out an SOS signal.
Yeah, like an internal alarm system.
The red alert invaders detected.
Exactly.
I like that.
And where do these pyrogens go? Well, they head straight to your brain.
To our brain.
Yeah.
Specifically.
To the hypothalamus.
What's the hypothalamus?
It's basically like your body's thermostat. It controls your temperature.
Oh, okay, got it.
So the pyrogens get there and they tell your hypothalamus, hey, turn up the heat.
Like crank up the thermostat.
Exactly.
Interesting.
And then all these other things start to happen in your body, like you start shivering.
Right, shivering. That's definitely a sign of fever.
Yeah. And your blood vessels constrict. It's all about generating and conserving heat.
So our body is basically working overtime to get that temperature up.
Exactly. And all that makes it a lot harder for those invaders, the bacteria and viruses, to survive.
It's like we're turning our bodies into this hostile environment.
Exactly.
I can see how they wouldn't be too happy about that. Imagine trying to live in a sauna all the time.
Yeah, not exactly ideal. But here's something I've always wondered.
What's that?
If fever is so effective, why haven't these microbes figured out a way to beat it?
That's a good question. I mean, they've had millions of years to evolve.
Exactly. It's a
Yeah.
bit of an evolutionary puzzle.
So you're telling me that even after 600 million years, fever is still a pretty good weapon.
Yeah, it really is. And that might be because of something called an evolutionary dilemma.
An evolutionary dilemma.
Yeah, it's like this. Imagine a microbe figures out how to survive those high temperatures.
So it can handle the heat.
Right. At first, that seems like a win for the microbe, right?
Yeah, for sure.
But here's the catch.
Oh.
That adaptation might make it less effective at infecting healthy people.
Oh, I see. So it's like a trade-off.
Exactly. If they become too good at surviving the heat, they might become worse at infecting people who aren't sick.
So it's like they're stuck between a rock and a hard place.
Exactly. It's this delicate balancing act that they haven't quite figured out how to master.
Wow, that is fascinating. So fever is like this ancient weapon, and it's still effective because it creates this evolutionary dilemma for microbes.
It's pretty amazing, right?
It is. But I'm still curious about what's happening at a microscopic level. Like, how does fever actually mess with those bacteria and viruses?
Well, let's start with bacteria. Imagine them, happily multiplying, setting up shop in your body.
Living their best life.
Exactly. And then suddenly the temperature starts to rise. They're hit with this intense heat wave.
I can imagine that would throw a wrench in their plans.
Definitely. This heat stress starts messing with their essential processes.
Like what?
Well, first of all, it can damage their DNA.
Oh, no, their DNA. That's like their instruction manual, right?
Exactly. It's their blueprint for survival, and the heat can start causing errors in that blueprint.
Yikes.
Then there's protein production.
Proteins. Why are those important?
Proteins are like the workhorses of the cell. They carry out all sorts of essential functions. But heat can interfere with how those proteins are made, causing them to misfold or not function properly.
So it's like their whole cellular machinery starts to break down.
Exactly. And to make matters worse, the heat can even start to rupture their cell membranes.
Rupture. Like Pop them open.
Yeah, kind of. It's like putting a balloon in a hot oven eventually, it's going to burst. And that's not good for the bacteria.
No, that sounds like a pretty messy way to go. So it's like fever is turning up the heat and basically making it really hard for those bacteria to function.
Precisely. And when it comes to viruses, the effects can be even more dramatic.
Oh, really?
Yeah.
Even more dramatic than exploding bacteria.
Definitely. But I think we should save that for after a quick break.
Okay, sounds good. We'll be back in a moment to talk about how fever affects viruses. Don't go anywhere.
So before the break, you were saying that viruses are even more sensitive to fever than bacteria.
Yeah, they are.
Why is that? What makes them so vulnerable?
Well, unlike bacteria, viruses can't replicate on their own.
Right, they need to hijack our cells.
Exactly. They depend on our cells' machinery to make copies of themselves.
So our cells are struggling, the viruses are in trouble too.
Exactly. That makes them really vulnerable to any kind of stress, including heat.
Can you give us an example? Like, how does fever affect a specific virus?
Sure. Let's take the common cold virus, rhinovirus.
Everybody knows that one. Right. It's a classic. And it loves the cooler environment of our upper respiratory tract, our nose and throat.
Okay.
But when it gets deeper into our body where it's warmer, it can't replicate as well.
So it's like fever is shrinking their ideal habitat.
Yeah, exactly. It's no wonder they can't stand the heat.
But how does fever actually affect the cells that are already infected with a virus?
Well, remember how we talked about heat stress and bacteria? A similar thing happens in virus-infected cells.
Okay.
These cells are already stressed out because they're making all those virus particles, and then the fever comes along and adds even more stress.
Double whammy.
Exactly. And to try to cope with this, they start producing a lot of these special proteins called heat shock proteins, or HSPs for short.
HSPs, I've heard of those. Don't they usually protect cells from damage?
They do. They're like little chaperones that help other proteins fold correctly and repair any damage.
So it's like the infected cells are trying to protect themselves from the heat.
Exactly. But here's where it gets really interesting.
Okay, I'm listening.
Our immune system has learned to recognize those HSPs as a danger signal.
A danger signal.
Yeah, it's like a beacon shouting, "Infection over here!"
So the virus's attempt to protect itself actually backfires.
Exactly. It's like waving a big red flag in front of our immune system.
And what happens when our immune system sees that red flag?
Well, we have these amazing cells called natural killer cells and killer T cells that are constantly patrolling our body.
I love those names. Natural killer cells and killer T cells.
Right. They sound pretty badass. And they are. They're basically assassins. And those HSPs act like a target, telling those assassins exactly where to go.
Wow, so the virus tries to protect itself, and it ends up painting a giant target on its back.
Pretty much. It's a brilliant evolutionary trap.
So fever helps our immune system target those infected cells more effectively. That's amazing.
It is. But it raises another interesting question.
What's that?
If fever is so effective, why do we always try to suppress it with medication?
Yeah, that's a good point. It seems like we're always reaching for the Tylenol or ibuprofen at the first sign of a fever.
Right. And it's important to remember that those medications are a relatively recent invention in human history.
So for most of human history, people just had to ride it out.
Pretty much.
Right.
And while those medications can definitely make us feel better in the short term,
I know I love them when I'm feeling feverish.
me too. But there's a growing debate about whether we're too quick to suppress fever.
Really? So what's the problem with suppressing fever?
Well, some research suggests that it might actually interfere with our immune system's ability to fight off the infection.
Oh, so it's like we're making ourselves feel better, but we're also potentially weakening our immune response.
That's the concern. And here's another interesting thing.
What's that?
There's not a lot of evidence that suppressing fever actually leads to better health outcomes in the long run.
That's surprising. So you're saying there might not be a huge benefit to always taking those fever-reducing medications.
Exactly. It's a more nuanced issue than we often realize.
So what's the bottom line? Should we just ditch the meds and tough it out every time we get a fever?
Not necessarily. It's important to remember that fever can be dangerous in certain situations.
Like when?
Well, for example, for pregnant women, seniors, or people with serious health conditions, fever can be more risky.
Right. Those are vulnerable groups.
And a very high fever, like above 40 degrees Celsius or 104 Fahrenheit, that's always a cause for concern.
Okay, so it's not a one-size-fits-all situation.
Exactly. It's all about finding the right balance and talking to your doctor to figure out the best course of action.
So fever isn't just a nuisance to be suppressed. It's a complex part of our immune response that can actually be beneficial.
That's a great way to put it. It's a sign that our body is fighting back.
And even though it might feel miserable, it's actually doing a lot of good.
Exactly. And remember, those microbes are having a much tougher time than you are.
That's a comforting thought. So when is it okay to just take a fever reducer? And when should we let the fever run its course?
That is the million-dollar question, isn't it? And it's a decision that should always be made in consultation with a healthcare professional. But for otherwise healthy adults, a moderate fever might not always warrant immediate suppression.
So it sounds like there are times when it's okay to let a fever do its thing.
Right, especially for healthy adults with moderate fevers.
hmm
But of course, always check with your doctor if you have any concerns.
But wouldn't that just make you feel miserable for longer?
Not necessarily. We tend to focus so much on getting rid of fever that we might miss the bigger picture.
Waiting.
Well, remember those pyrogens, the chemicals that trigger fever?
Yeah.
They don't just tell the brain to turn up the heat.
Okay, so what else are they doing?
They actually play a big role in activating different parts of our immune system.
Really? Like what?
Well, they can help boost the production of antibodies, and they can even stimulate tissue repair.
Wow. So it's not just about making things hot for the invaders.
Exactly. Fever is actually part of a much bigger process. It's like an orchestra with all these different instruments playing together to fight off the infection.
I like that analogy. So fever isn't just something we have to endure. It's an active part of healing.
Exactly. It's a sign that our body is doing what it's supposed to do, fighting back. So instead of viewing fever as the enemy, we can start to see it as our ally.
That's a great way to think about it.
Mhm.
So what practical advice can you give our listeners? What should we do the next time we feel a fever coming on?
Well, the first and most important thing is to talk to your doctor, especially if you have any concerns or if the fever is high or doesn't go away.
Right. Always good advice.
But for a typical mild fever, there are a few things you can do to support your body's natural defenses.
Like what?
Rest is crucial.
Yeah, that makes sense.
Your body needs energy to fight off the infection.
Okay. What else?
Staying hydrated is really important too.
Right, because you can lose fluids when you have a fever.
Exactly. And you can also do things like using cool compresses to feel more comfortable.
Okay. And don't forget about nutrition. Eating a balanced diet can help fuel your immune system.
Absolutely. So basically, listen to your body, give it what it needs to heal, and don't be afraid to let the fever run its course. Of course, within reason and with guidance from your doctor.
So it's all about finding that balance between letting our body do its thing and seeking medical advice when needed.
Exactly. Fever is a powerful tool that our bodies have developed over millions of years. It's a testament to the amazing ingenuity of our immune system.
This has been an incredibly eye-opening deep dive. I'm definitely going to look at fever differently from now on.
I'm glad to hear that. And remember, the next time you're feeling feverish, take comfort in knowing that those microbes are definitely having a much worse time than you are.
That's a great point. And on that note, we want to thank you all for joining us on this fascinating journey into the world of fever. Don't forget to subscribe, like, and comment to help others discover the show. And as always, stay curious.